Hey everyone, welcome to the video. Today we're going to be discussing about the AI technique Tic Tac Toe. And yeah, let's get started with this. So basically, AI technique Tic Tac Toe has three different approaches, such as approach 1, approach 2, and approach 3. And in order to characterize an AI technique, let us consider initially tic tac toe and use series of different approaches to play the game. The game tic tac toe is also known as Noughts and Crosses or XOs. Let's dive into the first approach right now. And the tic tac toe consists of 9 element vector called board. It represents the number 1 to 9 in 3 rows in this way. And an element containing the value 0 uh, is used to denote the blank, 1 denotes X, and 2 denotes the O. And the mutable vector consists of 19,683 elements, that is 3 raised to 9, and is needed where each element is a 9 element vector. So let's just assume the player 1 plays with an X and the player 2 plays with an O. So the player who gets three consecutive marks first, they would win the game. In this way, like it can be in a diagonal way, or it can be horizontal or vertical way. So this is how the board data structure looks like, and how the data tic-tac-toe algorithm works. So basically, the algorithm makes moves by pursuing the following: view the vector as a ternary number, convert it into a decimal number, and the step two goes like use a decimal number as an index to in a move table vector and access the vector. Set board to the vector, indicating how the board looks after the move, and it starts with an empty board as shown in here. And as I mentioned the steps earlier, we can just look through it with an example. Let's go along. Let's go likewise. Step one looks like this. Now our board looks like 0000. That is a ternary number. Let's convert it to a decimal number. The decimal number is 0, and use a computed number, that is 0, as an index into move table and access the vector stored in a new. In the step 3, vector selected in step 2 represents the way the board looks like after the move that should be made. So, like after completing the third steps, the board looks like this. And this is how the just an example how the conversion works. Basically, uses base 3, and using this, we derive this value. If we look into it closely, multiplied with the element value of 3 raised to 0, 3 raised to 1, 3 raised to 2, 3 raised to 3, so on. And this will give us the value 563 in a decimal value, I mean the base 10 value. And the move table algorithms looks in this way. It is a vector of 3 power 9 elements, each element of which is a 9 element vector representing the board position. The actual implement goes in this way. And let's dive into the advantages and disadvantages of this approach. The advantages is the advantage is this program is efficient in time, and the disadvantage is it takes more space to store the table and a lot of work to specify all the entries in the move table. Highly error prone as the data is voluminous. To extend the game starts from scratch. Like for example, if you have 3 years to 27 board position, then the huge amount of memory is required, which means huge complexities and poor extensibility. And this technique doesn't meet the requirements of a good AI technique because it should be optimal. Let's dive into the second approach. The structure of data is as before, but as we use 2 for blank, 3 for an X, and 5 for an O. A variable called turn indicates 1 for the first move and 9 for the last. The algorithm consists of three actions, which is make 2, pause 1, and go of n. So make two returns 5 if the center square is blank, as I shown in the earlier position. Like yeah, this is the empty blank, and you can see over here the data structure of the board. This is the center square, and otherwise it returns any blank non-corner square, that is 2, 4, 6, or 8. Pause when returns 0. The player P cannot win on the next move. Otherwise, it returns the number of square that gives a winning move. It checks each line using product 3 into 3 into 2 that gives 18, a win for an X, and 5 into 5 into 2 that gives a win for an O. And the winning move is a holder of a blank. Go off and makes a move to square an end setting board that is 3 or 5. And the main disadvantages we see in this approach is the algorithm is more involved and takes longer, but it's more efficient in storage, which compensates for its longer time. It depends on programmer skill. Another approach is called a magic square approach, where the representation of a board looks like this, and a magic square is consists of all rows, columns, and diagonal sum to 15. That's what you call a magic square. Like when you add all the elements throughout the rows or all the elements throughout the columns or diagonal wise, it should result in a sum of 15. Keep a list for each player of squares in which he has played. To check the possible win, consider each pair of squares x or y owned by the player. Copy the difference like z is equal to 15 minus x plus y. If the difference is not positive or if it's greater than 9, then the original two squares were not collinear. Means collinear points are the ones that line on the same line and so can be ignored. And this shows choice of representation have major impact on efficiency of the program. Let's dive into the final approach of tic tac toe. That structure of data consists of board, which contains a 9-element vector, a list of board positions that could result from next move, and number representing an estimation of the board position leads to an ultimate win for the player to move. And this final approach is also known as min-max procedure. In this algorithm, two players play the game. One is called max and one is called win. The goal of the player is to minimize the opponent's benefit and maximize self-benefit. Consider all the possible moves and replies that the program can make. Continue this process for as long as the time permits until a winner emerges. And then choose a move that leads to the computer program winning. Actually, this is the most difficult to program by good limit, but it is so as far the technique can be extended into any game. This method makes relatively fewer loads on the programmer in terms of good game and technique, but overall game strategy must be known to the advisor. And basically, this looks like this. And initially, let's assume this is the board positions of player one, and these are the few possible areas where player two can place the element. And if we place in this way, the X wins because the player one could go vertically, and if the player plays in this way, there is a huge possibility that there is chance for player two as well. If the player uh, puts the element in this position, there is again a possibility that X can win, and same for the last step as well. And if he chooses this step where player puts an element in the middle of it, means the center square, and ultimately the X wins. Uh, Thank you one and all for listening to the Tic Tac Toe AI technique.